Good afternoon. You are in the programmatic track here at Blackhat again, room Milano 1234. This talk is Attacking Java Clients by Stephen de Vries, who is the Principal Security Consultant at Corsair.
Right.
Take it away.
Thanks very much, Ricky. Everyone's aware that hacking ATM is in a different room, right? So this is boring old Java going on here. And basically, what I'd like to present is an approach and a methodology to attacking Java clients. And I'll present this approach from attacking a client from a black box perspective, so not having any access to the source code and not relying on decompiling to gain access to the code in turn. I'll also only be using high-level developer tools, so no directly editing bytecode, so you don't actually need to understand any bytecode to be able to attack Java clients. And then I'll only be using open source development tools as well. Right, so Java is the new COBOL, right? You know, it's an old technology, and it's precisely because it's such a boring and staid technology that financial institutions, conservative organizations, organizations that really don't want to be at the bleeding edge of technologies, you know, they want to try something that's been tried and tested, they'll stick to using Java clients. And we see a lot of Java clients still in banking applications, in trading applications, in commercial banking applications. And from a vulnerability point of view, what is interesting about Java clients is that often the security controls are built into the client side instead of onto the server side. And this is something that modern development environments make quite easy for developers. Well, it's easy for them to make the mistake of putting trusted code in the client side instead of on the server side. So we see things like this, for example. On the client side, if logged in, then user ID equals get the logged in user from a server, and then place an order on the server using this user ID and an order. So this is an example of state being stored on the client side. User ID and logged in are both local client-side variables. And if you can get into the client and you can manipulate these variables, if you can manipulate these fields, then you can change the way that this client-server application is meant to work. And this code looks fine to a developer. You know, if you look at this, it works, it's fine. The problem is just that if you assume that the client is untrusted, which is the case, all clients are untrusted, then you can potentially circumvent the logic of the client and the server. So when I'm talking about Java clients here, I'm referring to all types of Java clients. That's applets, applications, JNLP applications, and even the new JavaFX, which is really just a redressed Java. The difference in terms of running these on the client is you might have slightly different permissions by default on the clients, but you can change these. I mean, it's your client, so you can change the permissions to whatever you like. The point is that all of these are valid Java bytecode running on normal Java runtime environments. And all of them are subject to this approach. All the techniques I'll be explaining will work to all of them. So when we're looking at typical client-server application for Java, we have things like client side over here, server side over here. You have the JRE, the client running on the JRE, and then some kind of remoting interface here, the actual remoting transport, and then the server side. And Java is quite a feature-rich language, so there are loads of libraries and loads of different options you can use for both the client and the server side. For the transport, same thing. There's loads of different transports you can use, IOP over socket, IOP over HTTP, even a completely bespoke transport that the developer has invented for this particular application. And of course, EJB and RMI on the client side, or something invented specifically for this application. The point I'm trying to make is that if you want to try and intercept the communication between the client and the server, trying to go after the transport is quite difficult. You need to intercept a whole lot of different potential transports. The approach I'm going to take is to go at the client itself. So once you are inside the client, if we can get access to the client itself over here, we can then use whatever remoting interface is available and talk to the server, and then try and attack the server and try and circumvent the logic that's in the client. So some of the problems when you're doing a security assessment or when you're trying to attack a Java client, some of the issues you can run into are things like input validation. If you are testing a web app, it's really easy to circumvent the input validation. You can just directly manipulate the parameters, no problem. Doing that same thing on a Java client is a lot more difficult because you don't have access to those fields. You don't have access to those methods. The GUI also gets in the way of doing automated attacks. So it's difficult to do things like a brute force attack or enumeration attacks and so on. And then, as I mentioned, the remoting transport itself is difficult to intercept. Saying that, Manish Sandane released a tool at Blackhat Europe which will let you intercept serialized objects over RMI. So if the application is using RMI and serialized objects, you can use this plugin to intercept that communication. If the application is using something else, if it's using Spring remoting or if it's using a different type of remoting technology, well, then you can't intercept it. Decompilers, I think, is quite a popular way to go about assessing a Java client. As soon as you find a Java client, first thing to do is throw a decompiler at it and see what comes back. Problem is it doesn't work 100%. And even if it did work, say, 99%, you still wouldn't have recompilable code. So you'd have to try and reinvent that 1% that couldn't be decompiled, and then try and recompile the client, make your changes to it, recompile that again. It's extremely tedious. So the approach I'm going through is basically divided into two stages. Firstly, we want to understand the client logic. We want to understand how the application works, what are the important classes, and how the execution flow goes. And secondly, we then want to be able to manipulate the fields and the methods inside that application. And I'll break this down into a further 3 steps. Information gathering, probing and analysis, where we take a bit more active role. We actually want to see how the execution flow of the application is happening. And then thirdly, the exploit is where we actually try and circumvent the application. A bit more detail about what we're trying to do in each of these. Information gathering, we just want to find out what are the interesting classes. By interesting, I mean, where is the business logic? We're not interested in all the libraries and open source tools and so on that are included in this Java application. We just want to go after the core business logic. So where is that logic? Secondly, we also want to find out what are the methods that are available on the server side. So which methods are exposed by the server? And where is the comms layer? It ties up with the previous one. We really just want to find out how do we call the server-side methods. Probing and analysis is looking a bit more in-depth at the flow of the application. So we want to know where is the interesting execution flow, where is the key security logic. Is there any security logic in the client? There really shouldn't be. All the security logic should be on the server side. So we want to try and identify if there is key business logic or key security logic in the client. And then finally, for this approach, I'm using the technique of injecting a shell into the application. So we need to try and identify where's going to be the most convenient point to inject that shell. The exploitation, as I said, is going to be injecting a shell and then in runtime trying to patch the application. Or another technique is going to be static patching. If you want to override a method permanently, you can also do that. Both of those will be bypassing the client-side controls. Finally, once we're inside the app, we can then use the comms layer that's there to try and attack the server side. So we're free of the restrictions of input validation and so on, and we can try brute force attacks, injection attacks, and so on the server side. The tools I'll be using is the Eclipse Test and Performance Tools Platform, TPTP. And that's basically a profiler with some other tools mainly used just to find out how a Java application runs. And then some Eclipse plugin, the JD decompiler plugin, and AspectJ tools. I still see a lot of people using JAD for decompilation, which really doesn't work. It's many years since it's been updated. JD decompiler is written in Java and it works on the newer JREs. It's released both as a plugin and as a standalone app, and it's quite good. Then I'll also be using the Bean Shell and the Java Object Inspector. And I guess the star of the show is Aspect J. Aspect J will let us manipulate a lot of Java code without understanding bytecode. Right, I'm going to do a walkthrough through, well, I'm going to be demonstrating this through an application, and it's a very simple app. Client-server application. The server side is a Glassfish server. And the user logs in. So user logs in, they can click on an order, and they can view where their order was shipped to and where their order was billed to. Okay, quite simple. There are two users. There's Bob and there's Alice. Okay, and Alice can see these orders, and Bob can see the others. Right, quite simple. But immediately, just from that simple functionality, we already have a number of attack scenarios that stand out. Firstly, can Bob see Alice's orders? Those were just order numbers. So, can we manipulate the application so that one user can see another user's orders? Can we perform SQL injection attacks using any of those fields? And, for example, can we do an automated attack like brute force attack of login credentials? Now, obviously, to do something like the access control test, we can only click on order numbers here. So if I wanted to try and access Bob's numbers, the GUI just won't let me do it. It gets in the way, right? Similarly, if I wanted to try SQL injection, let's try simple SQL injection and login, blank password. Right, so there's some kind of validation going on the server side, or on the client side. Well, we don't know. It might be on the client, might be on the server. It's not letting us enter the characters to attempt SQL injection on the login form. So these are the kind of issues that we run into with Java clients. So step one is information gathering. What we're simply going to do is have a look at the content of the jar files. So the first place we start is on the program launcher. In this case, it's a batch file. If it was an applet, the launcher would be in the HTML source code, or JNLP, it would be in the JNLP file. The point is you always have a launcher, and the launcher would show you the class path and the main method. So the class path here already gives us some information. Remember, what we're trying to identify here is we want to find out where are the interesting classes, where's the business logic, and identify a point where we can inject our shell. So by doing a quick Google of the available jar files, we'll see that all of these belong to Glassfish. So we can ignore those. This is a common library. We'll ignore that. These two, admin.bean.jar and admin.client.jar, are bespoke. And this is the main method. So we know admin bean and admin client are of interest to us, and those are the ones we want to focus our attention on. So you open up Eclipse and just start a blank project, add the two jar files so that we can just have a convenient way to browse through them. So the main class, this was the main entry point. Not very interesting. It has a main method, has a launch GUI method. More interesting is client form. So this has got a lot more fields and methods in it. And Eclipse will show us by the red here that this is a private field, right? The green will show that this is a public method. So it shows all private methods. These look like GUI methods. So client form looks like it's probably a part of the GUI of the application. Right. The other interesting bit was admin bean, and if we look at that, it has an interesting interface. This interface has got methods: get order with an int, get order IDs, with a string, and login string string. Now it's an interface, right? If I double click this, JD decompiler will decompile it. How nice is that? Decompiling of annotations. But JAD doesn't do that. Okay. So we can see that this is an interface to something, and it's using the remote annotation. So this is a clue that this is probably using EJB remoting, which is part of the Java EE spec. If we look back at the launch code, it's including the Java EE jar file. Right? Another indication is probably using standard EJB RMI to talk to the server side. If we inspect some more, we'll see things like a field here, view orders, that is of type manage orders being remote. So this field is one of these, is an interface to this. And this has strong suspicions of being the server-side interface. Right? Okay. So another method, if you don't want to use the IDE to see the fields and the methods on a class, you can use Java P. Java P minus private means show all private methods. Give it a class path, give it the main class to use. And it will print out the same kind of information. So we know it's a public class, client form, extends a JFrame. It has a manage orders being remote, and it's called view orders. Right? It has an account ID field, which is a string. So lots of interesting information here. It has a login method, which is public boolean. Okay. So that's it for information gathering. We just want to find out where's the interesting classes, what is the interesting server-side method. If we want to call methods on the server side, where do we do it? So now we're on to the next stage. We want to do active analysis. We want to do active probing of the application. So the first technique I'm going to show you is using the profiler of TPTP. So we start a new profile configuration, external Java application, specify the class, which we will get directly from the run.bat file, specify the class path, which is also from run.bat, no arguments. In the monitor tab, we choose execution time analysis, and that's it. Okay, so that takes a while to run. So during the stage of probing and analysis, what we want to do is we want to find out how does the execution flow of the application work. Is there any logic in the app on the client side that really should be on the server side? And then try and identify this point where we can inject our shell. So as I said, I'm going to show you three methods. The first one is this one, is profiling with the Eclipse TPTP. The second one is going to be tracing with TPTP, and then tracing with AspectJ. Right, so Eclipse has launched this application in profiling mode, and Eclipse is controlling this app. It's logging all method calls. So I'm going to do a number of discrete operations. I'm going to log in as Bob. Okay, and I'm going to click on one order, done, and then close the app. Right. We now have the option to open this execution flow with a UML2 class interaction. So that's magical. Eclipse has given us a complete UML2 sequence diagram of every single method flow of the application without the source code. This is doing it just by monitoring how the application behaves. So if you're familiar with UML or sequence diagrams, the top row will give us the different classes that are involved, and top down gives us the execution flow. So we have here the main method, static main called, constructor, launch GUI is called, then we have some anonymous classes, etc., etc. If we look across for the other classes involved, there are a lot of proxies here. Here we go. These are some classes we're familiar with. The manage orders being remote and the client form class. Okay, so if we scroll down to see when something happens with those, here we see where client form is initialized, init component is called on it, some inner classes, initialization finished. Here we go, action performed. So action performed results in a method called login button action performed. This is when we hit login, right? After login, validate fields. That's going to be the bugger who's stopping us from doing the SQL injection. Then login. Login then calls another method login, which is on manage orders bean remote. And remember, this bean remote, this is our EGB interface to the server side. So whatever happens from this point onwards, you can see that as server-side interaction. So we call login on the server login method returns, the login method on the client finishes, and then we have populate order list, which in turn calls the server side. Get order IDs on the server comes back with something, and that method is finished. Right. Another action performed. The only other action we did was to click on an order, right? So order list box value changed. That results in get order on the server side, which in turn returns. And populate order details finishes, and we have some getters and setters on a model object there. So pretty handy. We have a complete diagram of all the execution flow of an application. And this all happened dynamically within the app. We didn't have to decompile anything. So another technique to get the same kind of information is to use tracing with TPTP. So tracing is basically inserting print or log statements into the application so that you can follow the flow and follow the variables as they're going along. Now, of course, since we don't have the source code, you can't go around and manually edit all the, insert all the print line statements or the log statements. So TPTP supports instrumenting bytecode directly by using probes. And I'll show you how we do that. So you start a new probe project. And this is a simple probe called a method tracer probe. This is the fragment, the actual code I want to insert, and it's just one line of code. I just want to do system out print line, the class, the method, and the method signature. That's all. Now these variables, the class name, the method name, and the method signature, you can define them up here. And TPTP will give you the option to use a number of built-in values that you can use here. Right. Then if you didn't want to do system print line, if you wanted to import some third-party logging library, you can do the import here. And then the final piece of the puzzle is the targets. Here you need to specify where you want to inject this code. So we're doing an include rule. Include everything in com.corsair.anything. This was the package used by our target class. All classes, all methods, all signatures. And exclude everything else. Right? So quite simple to apply this. We choose instrument, static instrumentation. And then we choose the target jar file. In this case, it was going to be admin client.jar. Done. So that bytecode has been instrumented. To run this new modified app, we need to change the class path. So all we need to do is use the existing run.bat script and add probe/bin, which is the directory to the classes of our probe project. Right, and that's it. Run with probe, and you can already see the print line statements coming out here. And this is the same information we had in the UML, right? Launch GUI is called. initialization is called, init components is called, etc., etc. And there's a lot of GUI activity here. So let's try the same operations. Bob, password, and login. And I'll click on one. There we go. So the same information here, except here as well we also have the arguments, the method parameters, and the return types. So it's easier to read. Login button, action performed, takes an action event, validate fields, returns a boolean. Login takes 2 strings and returns a boolean. Then it calls the server side, manage always been remote, login, and so on. Right, so this is similar information we got from the UML, except we also have the return types, we also have the method parameters on one screen. You could have worked this out from the UML if you take the UML methods and then go back to the jar file and open the jar file and then check the methods that were actually, or the parameters that were set for each method, you have the information there as well. I just find it's more convenient to have it all in one place. You have a complete trace of the application. Right. The third technique is to trace using AspectJ. So AspectJ, quick introduction, if you're not familiar with it, it's a Java implementation of aspect-oriented programming. So what AOP allows you to do is, if you've got some common functionality that really has to apply to all of the classes in your application, instead of manually going and editing all of your classes, you define it in one place and you tell AspectJ, put this into my application. So very similar in principle to what TPTP did, except this is now a developer tool more than a profiling tool. So when AspectJ started out, it only allowed you to do source code weaving, which was a bit pointless for our purposes, but now it allows you to do bytecode weaving. So we don't need the source code. We can directly inject into bytecode using AspectJ. Some terminology here. AspectJ calls advice is the new code that you're going to insert. A point cut defines where you want to insert this new code in your application. And you can use regular, well, it's almost like a regular expression. Then the aspect refers to the advice and the point cut. Gives you the aspect. Here's a simple example of what an aspect looks like. Say we had a simple application. We just wanted to, print out when we're about to call a method called set something. And we wanted to print out again once that method has finished. This is what AspectJ code would look like. So you define the point cut. Where do you want this code to apply? It must apply to all calls to any method with a void return type that starts with the letters SET and anything after that, and any number of parameters. We want to run the advice before this match. We want to say we're about to set something. And we want to run advice after the match, which is that we completed setting something. So we'll do a similar kind of exercise what we did with TPTP. We will just log method calls. One really nice aspect of AspectJ that you don't get with TPTP is that you can also log internal field assignment. So where TPTP just showed us which methods are being called, we can now also see if there are specific fields being assigned within the class, even if they're private fields. Right, so a simple tracing aspect. This is what it looks like. All of this is just regular Java. This is just to make the display a bit pretty. Here's the AspectJ bit. So we define a point cut, my class. That must be within the com.corsair.anything package and not within com.corsair.aop package because I put the aspect itself into this package. So don't insert into yourself, basically. Okay. This is just so that we don't get too much information from all sorts of other libraries. Right. I want to match all constructors. In other words, it must be in my class and match execution of the new method. Match all methods. In other words, a call to any return type, any method name, any number of parameters. And then here's the nice bit. which is field assignment. Match any assignment of any field. That's also in my class. Again, we're going to be running before and after advice. So before constructor, after constructor, before method, after method, and then assignment. This join point static part is a keyword for aspect J, and this gives us some information about where we're injecting to. So when we print out here, this join point static part.getSignature, we have information about the method we're injecting to and the parameters that it's using and the return type. To apply this, we use the AJC command. If I can find it here. So AJC is quite similar to JavaC. You specify a class path. We need to specify the aspect J runtime library on the class path. Other than that, it's the usual class path that we found in the run.bat script, right? Point it to our aspect. Give it our target jar file, and we'll write out the new jar file to a new jar file called new admin client. Right. So that's it. It's now created the new client for us with that code inserted all over the binary. We can now run with the aspect. Lots more trace information. Okay, this is also just initialization, right? So we haven't done anything on the app. You can see here it's doing, this is a lot of GUI activity, org.jdesktop layout, blah, 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 etc. But here we have the core logic, init components, setting something visible, launching the GUI. Same operations, Bob, password. Okay. And let's look at the login method. Right. So we're getting here get text, gets the username password field. Login method on the client form. Now we see something here that we haven't seen before. That there's an internal field assignment, client form.account ID gets the value of null. Then it calls the server-side login, server-side returns. Then it sets account ID to some value, right? Account ID is an internal private field. Does a comparison, and then login on the client is finished. Populate order list is also interesting because this also calls the server side. Get order IDs on the server side. It returns a list. It then converts a list, probably that one, to an object array. It then calls set list data on a JList control. A JList is a GUI control to hold a list of objects. And it uses an object array. So from this, it's quite clear what's happening on the client, right? It gets the order IDs from the server side as a list, converts them to array, then sets that array onto the JList control, and you have those order IDs populated in the list box. So we click on it, click on something, and we see a lot of activity. Right. So this technique of tracing with aspect J is, I think, the most powerful of the three, because it gives you access to internal fields, and aspect J is an extremely rich programming environment, so you can be very specific about where you want to insert the code, what you want to see from it, and so on. So we're now into the final stage. We've done the analysis. We understand pretty well what the application is doing. We know which are the server-side methods. We know when it's calling them. We don't want to get to the stage where we can call those methods and we can do whatever we want with them. So we can run those three attack scenarios I mentioned right at the start, which is try and subvert the access control, try and view other people's orders, try and perform SQL injection attacks, and then try and perform automated attacks. And I'll demonstrate two methods, the injecting the shell and then doing static patching. So a quick intro into two tools, the Java Object Inspector and the Bean shell. JOI is basically a simple application used to debug an application. If you don't want to use a debugger, say you've got a complex server-side application, you don't want to try and debug that, start that up in a debugger, you can insert the JOI into it, and the JOI basically just gives you a GUI that you can see the fields and you can set field values for primitive types of anything that's in scope. It's very easy to use. You just import it, you call one command, inspector.inspect, you pass it the object you want to inspect, and it will give you a GUI with all those objects fields on it. That's what it looks like. Bean shell. Bean shell is a complete scripting environment for Java, and it's also an interactive shell environment. So it provides kind of a superset of the Java language. You can either use strict Java if you like, or you can use excuse me, the simplified Bean shell script, which is a bit of a shorthand. To start it up, you create a new interpreter. You can then pass in any objects into the shell that you want to have a reference to. So if you have a my object, you can call it my object and pass it to the shell. You can then start up a server in the application. So it'll actually start up two servers. It'll start up a telnet server and a web server within the app. And it doesn't matter what the app is, even if it's an applet, you can start up a web server inside the applet, which in turn serves an applet. This is a telnet server. It's well, not very friendly to work in. It doesn't have history completion and so on. The HTTP server that it starts up will give you a nice little applet, and that gives you an easy-to-use interactive shell. So you are then inside the application. What the Bean shell lets you do is, same as the JOI, it lets you view fields, lets you edit fields. But of course, it's a complete shell environment. So you can write scripts, you can execute any method, you can instantiate classes, you can basically do whatever you can do in Java in the Bean shell. And these are the three components we have. We have the Bean shell, which gives us an interactive scripting environment. We have the JOI, which is a easy-to-use GUI for editing fields. And we have AspectJ, which gives us the ability to rewrite methods or to insert code into bytecode. So in order to insert these, I want to insert them into the application. Now, two things to bear in mind. If you want to insert the Bean shell or the JOI, you really only want one instance, at least, of the Bean shell. So you need to find a place in your code that only gets executed once. And also, you want to insert it in a point where you have access to the interesting classes, to the interesting bits that you want to run. So in our case, if we look at the admin client, for example, view orders is the EJB. View orders is the remote interface to the server. So if we have access to view orders, then we can call these methods on the server side, right? So ideally, we want to be inside client form, or at least have a reference to client form. If you go through the trace information, I'm not going to do it now, you'll see that the constructor for client form only executes once, right? So we only have one GUI, so a convenient place to insert the shell is in the constructor of that GUI. So we know where we want to insert. Now we just need to go and insert it, again with an aspect. So create a new aspect, interpreter I. We define the point cut. Where do we want to insert this? It's going to be on the execution of client form.new on the constructor, right? We want to run it after the constructor executes. Nice thing about after advice is it leaves the rest of the program intact, right? So if the constructor was doing important initialization or whatever it's meant to do for the application, we leave that untouched and that will still run, and we'll inject our code after that. So very simply, we just print out that we're injecting the shell. We start up the interpreter. This again is a reserved word. This join point.getThis gives us a reference to where we're injecting. So we're injecting into client form here. This is going to give us a reference to that form, and we're going to call it form. Set accessibility true is basically used for reflection. So if you want to access private fields and private methods, usually you can't do that within Java because of the scoping rules. It'll only let you access public fields and methods. Set accessibility true turns that off. So you can access private fields and methods. Then we're going to start the server on port 7777. Once Bean Shell is injected, we're then going to inject the JOI, might as well. And again, we're going to pass it a reference to the form. So similarly, we'll use the AJC command exactly as we did for the tracing, with the exception, where is it? Well, the only addition we have to make to the class path is we just need to insert the Bean Shell jar and the JOI jar. And the rest stays as is. Okay, so we're going to inject our shell. Done. Now run it. There we go. This is the JOI that has popped up, and as you can see, it will show us all private, protected, and public fields for the form. Here's our form. So we just log in as Bob. So we can see things like the account ID field is this value. And if we wanted to, we can change that value. Right. So just an example, there's a JLabel field called login message label. I can choose to inspect that again. Remember, you can only change and view primitive types, so it's a complex object. You have to inspect that and then try and change any of the primitive fields. This has a text property, welcome Bob. So we can change this. And if we redraw the GUI, it's changed, right? So JOI will let us change any arbitrary fields anywhere on this client form. But we're still a bit restricted. We can't call methods. We can only change fields. So it's not the full show. If you wanted that, we just need to log into our Bean Shell instance. Remember, Bean Shell has now started up 2 servers running inside this application. It's running on it's running a telnet server, and it's running this HTTP server over here. Remember, we gave the reference to client form and called it form. So if I print form, there is an object called form in reference here. So I can print form dot. So we have access to that field as well. Okay. So far so good, but the interesting stuff is going to be in this EJB method, or the EJB class. View orders. Remember, view orders exposes all of this functionality. So the first thing, I'll just get a reference to view orders. It's going to be form.viewOrders. And remember, view orders is private. The only reason I can access it here is because I set accessibility to true on the Bean Shell. So we have access to that EJB. Let's try something like ejb.login. Nonsense. So a failed login returns null. and successful login returns the account ID by the looks of things. All right. Well, now we're in a position to try a bit of SQL injection. Blank password. And it happens to work. So this only works because the validation, the input validation of these values is being done on the client and not on the server side. So this is a misarchitecture of the application. All this security components, the input validation and so on, this really must be implemented on the server side and not like it's done here on the client. So while we're doing this, we may as well do something like brute force usernames. This is bean shell scripting, reading a number of passwords from a dictionary. No, a number of usernames from a dictionary file. Right, this is all pretty familiar Java stuff. Try and log in using our SQL injection with the given username. If it succeeds, add it to an array. And pretty easy to call scripts that you've written with the bean shell, like so. And it will run through the script and find the examples. Yeah. So, sorry, actually, can we wait till the end? Because I'm running a bit tight on time. Thanks. Right. OK, and then, of course, the key that we wanted to test was access control. Can Bob view Alice's orders, right? So if we look at the GUI, Bob can view 001, 007. He can't view 002. So that's the first thing we'll try here is O equals. Now the reason I know this is because we can see the methods on this interface here. So we know what we're going to call get order with an integer, right? So we're just going to try different integers. So pretty simple. EJB.getOrder 1002. Okay, there is an object there, and we can inspect the fields on that order class, build to first name. Belongs to Alice. Right. So again, a misarchitecture of the application. The state is being stored on the client side, and just because the GUI is in the way, there's a false sense of security that you can't actually view other people's orders. But on the server side, if you can call those methods directly, you can view those orders. Right. Now, once you've explored the application with the bean shell, perhaps what you want to do is overwrite methods completely with aspect J. And this means that you will permanently change this jar file to behave as you want. And I'll be using a new type of advice here called around advice. Now, around advice is different to before or after in that you can optionally choose to ignore the original method. So if you wanted to, you can run something, you can run some around advice which executes before. It then calls the original method and then executes something after. Or you can just overwrite the method completely. So going back to that login functionality, this was the trace of what happens during login, right? This was using aspect J to do the tracing. And this is what came out. Client form.login calls the server side login. It then sets the account ID. It does a comparison, and then it exits and returns a Boolean, right? So if we wanted to rewrite this method, what we could do is just ignore the server side, set the account ID directly, and then just return true at the end. Okay? And that's what we can do here with aspect J. Just get rid of this code for now. So we define the point cut. The point cut is going to match exactly our client form.login method with 2 strings as an argument. Conceptually, all we want to do is form.accountID is the account ID and then return true. But we can't do that because account ID is a private field. So all this code is really just to use reflection to get a hold of the class, to get a hold of the field, turn accessibility to true again so that we can access private fields, and then set the value on the field. Just a longhand version of doing this, effectively. Okay. So we apply that advice. Oops. Done. Advice applied. We now run with the advice. And now we've patched the login method. Doesn't matter who we log in as. It's going to log us in as Bob because we've set the account ID manually to Bob's ID. And we can view Bob's orders. Right. Just to give you an idea of what you can do with aspect J, from this practical point of view, it was a bit pointless because we had to know Bob's account ID in the first place, right? So if we wanted to test something like the access control, if we wanted to test whether, whether Bob can view Alice's orders, what we really wanted to do is to be able to set that list box and insert the order numbers into that list box. And we can do that too. So we define a new point cut. Let me just show you what that trace looks like to refresh your memory. Populate order list. This is the method that was populating the order list, right? So it called the server side, get order IDs that returned a list. It converted the list to an array, and then it set list data using that array, and that was the end of it. So we can do the same thing. We just won't call the server side. We'll just create our own array, right? And that's what this code does. Again, I have to use reflection because order list box is a private field on form, so we can't access it normally. So have to use reflection, have to turn accessibility to true, and then eventually we can access it. So I create my own array here, 1001, 1002, 1003. That should belong to Alice. These two should belong to Alice, right? Login needs to be a whole lot simpler. We just need to return true. Since we're not using the account ID, we just needed to log us into the GUI, right? Actually, it doesn't matter who we log in as, right? It returns the orders that we placed in it. So we've permanently patched the application to behave as we like by using aspect J. So basically, what I've demonstrated is that you have a lot of power using simple open source developer tools. You don't need to understand the bytecode, and you can override and overwrite client-side Java code. You can trace application flow using aspect J and Eclipse TPTP. You can get UML2 diagrams right out of Eclipse TPTP to try and understand execution flow. And then you can manipulate the final client either permanently using AspectJ or insert a bean shell, insert a JOI, so that you can play around interactively and find out what's going on inside that application. I want to close with a mention of Arshan's talk, which is happening in the Neapolitan room in just a few minutes. Now, I didn't mention Java Snoop because it hasn't been released yet. It will be released in a few minutes. And it's really a GUI that makes a lot of the bean shell, well, the functionality that I took out of the bean shell, you will get with Java Snoop. It's an easy-to-use GUI application. You don't need to inject anything. It will automatically let you select from a list of running Java processes, select the process, and you can then intercept method calls. You can set fields. You can do all sorts of fancy stuff with it. So recommend you attend his talk if you're interested in the subject. Yes, there were questions. Sorry?
So with some of the examples that you showed, SQL injection, what have you, have you tried remote code execution on the JVM within the server?
I haven't tried it, but I mean, that's certain. Oh, yes. Sorry, the question was, have you tried remote command execution on the server side? Right?
You'd be stuck in the JVM on the server side.
You would be stuck in the JVM, but for example, if you wanted to exploit a bug in the JVM on the server side, you could try and do that from the client. It all depends on how what the transport does to your exploit, as it were, or your payload. You know, if it mangles it or if it doesn't work properly. But certainly that's conceivable. I mean, once you have the remote interface, you can call whatever you want on the server side.
If I could run the server side, if I could run the server and do this stuff, does this stuff work well on the server side as well? Like, if you got a big server with a lot of code,
Yeah.
some of these things.
Yeah, sure. As long as it's, sorry, the question was, can you run this on the server side? So, for example, can you inject the bean shell on the server side, or can you inject the JOI on the server side? You certainly can, yeah.
The tools like the object inspector, they fall down and you get a huge.
I guess if it's a GUI tool, it would, but if the bean shell won't, because it doesn't need to keep anything in context. So you can have a scripting environment inside your server-side code, and I think that's probably the legitimate use of the bean shell. What developers normally use it for is to do that kind of thing. All right. Any more? Yes.
Are you going to be releasing the examples that are open demo?
I really should, shouldn't I? Yes. Have a look on Corsair's site, www.corsair.com. I'll post them there shortly.
So
all right.
Tracer API, I think, and
Yeah. And also the example application, if you want to run that.
the bean shell.
Yeah. Yeah. Okay. Great. Thank you very much.